Good morning and welcome to the Sanvian Technology Walk. This is what I'll be taking you through some of our new technologies that will be going out to the field, showing you how we field test them and bring these products to commercialization. So I'm going to show you our latest IntelliScout. This is a smart motor. We have measurements built into the motor to be transmitted real time, and this allows us to get near bit measurements closer to the bit to improve drilling performance and placement of the wellbore. So this is the IntelliScout rotor. We've already loaded up the inside of the rotor with the IntelliScout electronics, and this gives us near bit inclination, RPM and shock and vibration at the base of the rotor. We then have a conductor rod. It runs through the board rotor all the way up to the top of the rotor, where we would have the rotor catch. Rotor catch isn't on yet, but the rotor catch would be here. On top of the rotor catch there'd be a transmitter. In the MWD directly above the motor there'd be a receiver, so we can receive the real-time data coming from the rotor. So this motor will be going together this week. I'll share with you a video when we go through pre-qualification before it heads to the field test. And this is to get the data transmitting real-time through the Scout MWD system. Okay, here we are up at Turbodrill Industries. We're doing a test on the IntelliScout rotor. We've decided to do it in the breakout machine. So what we're doing is just rotating the rotor with the antenna on the top end. So this is the antenna on the top end of the rotor catch, and the rotor fitted with electronics. So doing a rotation test right now. So when it wakes up down hole, it will start transmitting inclination, RPM and shock and vibration. Okay, well, we've made it out of West Texas. We're about to run in hole with the IntelliScout motor, drill this lateral, and then we'll come on out and head back to Houston and pull the data from the motor and see what we have. Okay, so here we are back up at Turbodrill Industries. The motor's just returned from a test in West Texas. Just pulling in on the truck right now, about to offload, take it apart and see what data we have on board. Okay, that's the conductor rod removed. Starting to remove the sensor packages now, and they'll go off to get downloaded. Okay, so now we're going to take a look at the data that was gathered on board the IntelliScout motor during the last field test. This plot shows the near bit inclination that's measured inside the base of the rotor. On the vertical axis we have inclination, and on the horizontal axis we have measured depth. The red dots indicate the static MWD surveys along the length of the lateral. The continuous blue trace is the inclination measurement from onboard the IntelliScout motor. Now our target for the inclination measurement accuracy was to be within plus or minus 0.2 degrees of the static MWD survey. One point of interest you can see here is that in rotary mode the assembly is building, and then the directional driller slides down to compensate. Rotary, building, directional driller slides down to compensate. So with IntelliScout we can clearly see the tortuosity of the wellbore between survey points. So what does the IntelliScout give us? Well, it delivers real-time near bit inclination, drill bit RPM, drilling dynamics, motor backdrive detection, HFTO frequency and G-force severity. And this results in informed decision making from real-time measurements actually onboard the power unit of the motor, optimized rotary and slide parameters, reduced slide time because the directional driller now knows the exact inclination of the drill bit. We now eliminate the guesswork because of the measurements closer to the bit, and we can improve the drilling pace and reduce the risk. So IntelliScout is compatible with any motor power section. Inside the rotor, we have a sensor package at the bottom with inclination, shock, HFTO, RPM, and temperature measurements. Then we have a conductor rod that runs through the board rotor up to another set of electronics, the SAN hop EM short hop electronics that drive the transmitter to transmit the information to the MWD tool. This package in IntelliScout is completely self-contained within the rotor and the rotor catch. There are no wires coming outside, and we've done this to improve reliability and increase the pace of maintenance of the product. We are compatible with any top mount MWD tool. We have a simple and reliable short hop design. Here we can see the transmitter directly mounted on the rotor catch and the receiver mounted on the MWD string. IntelliScout can also be used with RSS BHAs, and it does give significant cost-saving advantages. With IntelliScout, we only need to run the RSS below the IntelliScout motor. So it would just be RSS, IntelliScout, and MWD mounted behind the IntelliScout, and we receive real-time information from the IntelliScout. Typical RSS BHA in North America land would run RSS, MWD, non-mag spacing, and some sort of high-frequency torsional oscillation isolation tool all below the motor. With IntelliScout, we don't need to do that. This allows us to reduce the HFTO severity and increase RSS life without these expensive isolation tools in the system. We reduce lost and hole risk because we now have less equipment hanging below the motor, and we can deliver real-time inclination 12 feet behind the RSS, RPM verification for RPM downlinks, and drilling dynamics measurements. We have published a technical paper on IntelliScout. SPE 201551 can be downloaded from One Petro if you want to read about this further. So that's IntelliScout. It is really an industry first, providing real-time power unit measurements. We're now taking the measurements inside the power unit closer to the bit rather than inside the MWD. Stay tuned for more updates. We have some more exciting measurements coming from IntelliScout, and I'll be covering those in the next edition of the Sanvian Technology Walk. Thanks for your time, and talk to you soon.